It's really important to be looking at whether what you're doing is growing you, where do you want to be long term.
We started using a lot of tools like Cursor AI or Copilot.
And oh my goodness, no one ever thought of doing this.
The rise of GenAI. Hi everyone and welcome. Today we're excited to have Paul Leventis, VP of Software Engineering at Databricks. Hi Paul.
Hi Yosef.
Hi Gwendon.
Hey, nice to have you, Paul.
Yeah, we're so excited. And first, can you introduce maybe yourself to the community?
Yeah, so I'm Paul Leventis. I'm a VP of Software Engineering here at Databricks. I joined Databricks about 5.5 years ago, moving to Amsterdam from Toronto to take the role. And prior to that, spent 20 years working in tech, always for American companies from satellite locations. Some time at Google, about 5 years, and some time, about 15 years in the semiconductor industry working on field programmable gate arrays and the software for them.
I was looking at your resume in LinkedIn, and it's super extensive one. But my question is how did you become a VP of Software Engineering, and why Amsterdam? Because I know you used to live in Canada, I guess.
Yeah. It's a fun story. How did I end up at Databricks is straightforward in a sense. And one day, Reynold, one of our founders, had reached out. He was just curious to learn about the Canadian tech market for some research he was doing into possibilities of what we do. I ended up, as Reynold, by the way, is a master recruiter. He is one of our top recruiters in the company. He's brought in amazing talent to this company. But, he is obviously ends the call with, hey, so what are you doing? And are you interested in doing something different? And one thing leads to another. And I was interviewing for a different role with Databricks. And during the interview, Ali heard that I was visiting a relative I have in the Netherlands. My mother was born in the Netherlands and my grandmother still lived here. And so I was actually that week happened to be flying out to visit her. And he's like, oh, wait, Netherlands, huh? Have you ever considered living abroad? What about Amsterdam? And I'm like, yeah, my wife and I were thinking about it. Our kids were 8 and 10 at the time. We're like, if there's ever a time for us to go live abroad for a bit, this is a good time. One thing led to another. And, it was as I like to say, it was the first sort of Databricks monkey wrench, as I like to say, where we often are willing to make very fast, rapid changes and very biased for action. And that was me seeing it in action from the leadership in that moment where it pivoted into a discussion of a leadership role in Amsterdam. So as a company, we had a growing Amsterdam office and, someone who'd done, Peter, my predecessor, who'd done a great job growing the office to the size it was. But we needed, someone with a bit more experience running a larger site to come in and help the site continue to grow. So that's how I ended up here. And then, why Amsterdam? Besides the family connection, I'd been here before. It's an amazing city, great place to live. I could imagine bringing my kids here and them having a wonderful time, both in the city, but also exploring, Europe as a whole. So I thought it would be a really neat experience for them and for my family as a whole.
And I can assure to the viewers, this podcast is not sponsored by Amsterdam.
What's your... which city do you like the best, Toronto or Amsterdam? And wait, be careful because I live in Toronto. I even put my Banff t-shirt.
Yeah.
So you have to...
So I grew up in Toronto. I've raised there. So obviously I love a lot of things about Toronto as a city, and my friends and family are there a long time. But honestly, I've come to really enjoy living in a smaller city than Toronto. So the fact Amsterdam's kind of a right-sized city, so I can get anywhere by bicycle safely without fearing for my life, and can do it in 15, 20 minutes to anywhere in the city, but also can be in countryside in 5 minutes and go for lovely long bike rides. So I secretly, but don't tell anyone, really kind of prefer Amsterdam if I had to pick.
And to go back to your role at Databricks, can you tell us more about the VP role? And is it mainly about managing, or is it about team management? Are you technically involved in the architecture decision, or maybe do you rely on your team's expert to take those kind of choices?
So at Databricks, we have highly technically engaged management. So it's a company that's run from the top down, in terms of, founders in early VP roles of the company who are very deeply engaged technically. But all of the people we've hired after that, we aim for everyone down to line managers up through the VPs to have the ability to engage technically with their teams. Now, that said, that's not always where our skills are most needed. When you have a team that has great technical expertise and are making awesome technical decisions, but needs to grow and you need to recruit, maybe you're spending most of your energy recruiting, or the org is struggling and needs help with how it's organized, maybe you're spending your energy there. So in general, as a manager, you're kind of balancing these sort of 5 different ingredients, your strategy and your execution and the technology and the product direction and the people, and kind of balancing these different factors and gap filling wherever it's most needed in the team. That's true at the lowest levels of management. It's true all the way up at the VP level, I'd say. But in my past, at Databricks, I've managed directly a team working on the Photon engine, which is a very technically complex project. I helped execute the Databricks SQL product and get it out the door. That was more of an execution and program management role more than anything, though there were technical choices there. And at other times, I've been focused on how do you grow an office, deal with issues that you might have in a site. So I just walked out of a meeting with our Works Council. So how do we deal with employee relations? How do we deal with changes to perks or benefits or the work environment? Or last week, there was a complaint about us serving only 1 meatball at lunch per person. So the nature of my job is highly varied depending on the day to day.
Do you want to go ahead?
I got you with the meatballs, didn't I?
I wasn't expecting a VP facing those kind of issues.
Well, and again, like anything, you hope to surround yourself with a team of people who are awesome at their jobs in all the different jobs that we have done. We have great facilities people and great people on the HR and the legal and so forth sides to deal with many of these different issues. But you're helping to ensure that things that aren't getting dealt with or are escalated do get rerouted correctly, and helping to debug and diagnose and problem solve. But in the end, you're trying to match the right people to the right.
So you just mentioned Photon, and you was working on Photon with your team. I think it's a good topic because I wanted to talk about innovation a little bit on data engineering. Well, maybe we can start. Can you share a bit more on Photon? What is it doing? Kind of how is it working at a high level? And then I guess the follow-up question would be on innovation. Like, how do you drive innovation as engineer? And I think Photon is a good example of that.
Yeah, so Photon was our effort in about 2019, 2020 to 2021, 22, and still ongoing, to basically rewrite the guts of the Spark distributed data processing engine, which is at the heart of how Databricks does large data processing. Rewrite the core of the processing engine in C++. And so it's writing it in a native language instead of Scala or Java, but writing it in C++. Also leveraging simultaneous sort of SIMD instructions in the processor. So basically, how do you process multiple pieces of data with a single instruction? So this is a capability processors have, but it requires relaying out data, looking at data in a columnar rather than row-wise fashion, and handling things in batches. It's a very interesting approach that if you handle your data in just the right ways and the right orientation, you can leverage the layout of data in memory and the way processors want to process that data to do processing in substantially faster ways. So, if you think of Apache Spark is really an API, an interface, a way of doing data processing, and then there's a open source implementation of all aspects of Spark. But this was replacing at the lowest operator level how those operators are executed with Databricks proprietary implementation. So that's what the Photon engine was basically slowly over time handling more and more and more of those operators and speeding each of them up. In that case, our target was starting with getting it to be 2x faster for every single operation that we touched. And then how you sort of approach, so that's just an example of a great innovation challenge. That was one that was started by, Reynolds saying, hey, we need our engine to be faster. Let's step back and build something. It's going to take us 2 years to get there. And some amazing people who had incredible experience on this, and amazing engineers working on this who had various ideas. And then just, the way that, the funny thing is, a lot of innovation, occasionally innovation is like eureka moments and, oh my goodness, like no one ever thought of doing this. But sometimes it's just a lot of elbow grease. It's like, hey, how do we systematically look at each operation and, make a change, measure it, make sure we've got the improvement we wanted. And actually a hard part of it is deciding to move on to the next thing, not sitting there and playing with the thing that's fun to play with and get another 10% when you have another target available to you that you need to make 2x bigger. That's one thing that happened during that time. But the way that the innovation works there is, there's a mixture of sources of ideas, and engineers read an interesting paper or looked at the patterns that they saw in the customer data and said, hey, wait, the way we're approaching the data is this way. If we oriented it that way, it would be faster. Or they're profiling it, they're brainstorming. We have outside experts who've seen things, or we go to a conference and listen and hear things. And the key thing is that you're getting exposed to many different ideas from many different sources, and your team has the freedom to think about those pieces of information and synthesize them and collide with each other and come up with, something new. But occasionally innovation is this big leap, but often it's just selecting the right problem to work on and setting a ambitious goal, but, then making incremental progress towards it. So if I take Photon, it would have failed if we say we're going to rewrite the entire engine and replace the whole engine at once, because it's extremely difficult to catch up with all of the capabilities and prove that you have an engine that is compatible. Instead, the key idea that allowed us to get there was saying we're going to take one operation at a time, the bottommost part of the tree, basically, and say that's operation we're going to make faster. And we're going to otherwise make the engine completely compatible. And we're going to piecemeal replace little parts of it until one day all of it has been replaced. And that sort of approach was critical to being able to execute on a big, audacious project like that, especially with a relatively small team like we had at Databricks when you look back 5 years ago.
Yeah.
Yeah, and I think what's impressive is when you do that, it's like, how do you know at the beginning that it's going to work at the end? Because, you start by the small piece, but I can really see with such a project how you start with something and then you realize maybe 1 or 2 years after, or no, it's not that good. I've seen that, for example, I used to work at DataStax, and they did something kind of the same idea. They wanted to improve the engine of the database they were working on, and it took them maybe 2-3 years to release something, and they had to they rolled back everything after 3 years. They basically destroyed everything. It wasn't working how they wanted, and they removed it. So I can see how very easily you can get trapped like that in things like that. Yeah, I don't know. Do you have any secret sauce to avoid that?
Yeah, well, that's wherever you can make an incremental change, it's always, especially in a production, industrial kind of product, we don't have the luxury that you have in, let's say, academia, where you can say, I'm just going to start again, and I'm going to show that this works fine on TPCDS or some benchmark, and show that that it works good on this one benchmark. That's my only objective. I publish my thesis and I move on with my life, right? It's you have customers using the product. You have lots of real world cases that need to continue to work. So doing a complete wholesale replacement of a product, it's very difficult to ever get there. When you're doing it in place upgrades and piecewise upgrading and changing things, you can take advantage of techniques like A/B testing, where you can have both code paths available, and you're doing a read-only version of the change under the new code path and double checking that the outcome is the same as the old code path, which is still being used in production, or vice versa. These types of techniques, anytime you can find a way to gradually change and be able to, especially if you can test in production without affecting your customers' workloads, or you have a way to very quickly detect regression and roll back in the case. But again, if you release a big bang piece of software and then you have to roll it back, your option is to go back to the version you had 3 years ago. You're kind of doomed. You're never going to ever get to the conclusion. You have to be able to make incremental progress and roll back incrementally. Otherwise, you'll never get there.
Yeah, and just, I think, just a reminder first for those who are like watching this recording, Photon is our vectorized engine that, as Paul mentioned, like has been written in C++, and the goal is that it speeds the process. You don't need to change your Spark code. Basically, if the function can be photonized, then it will run on Photon. Else, it will fall back to the like regular Spark engine.
Exactly, and it's making those decisions like not all or nothing. It's making the decisions on an operation by operation basis.
So I think that's what almost everybody does now. Like DuckDB is kind of doing the same. All the big players are doing the same. Do you see a new, like, what's going to be the step after that? Do you think we will go to GPUs? Well, do you have any?
Not really my area of expertise, to be honest. I don't know what the right next thing is. I mean, my own personal background is in optimization software. So I've seen some of these trends over the years, single threaded to parallel and SIMD and, data layout. It's always shocking how something looks like it's a solved problem in computer science. Let's take databases. They've been worked on for 50 years or more. And yet you keep coming across things that are new ideas that radically rethink how to do something. Or sometimes it's just an old idea that now, because of the trade-off of time time or cost in the system, like, SSDs come along and suddenly it changes. What does it mean to spin the disk? It's very different than if you have a spinning disk. Or, memory becomes cheaper or faster, or these other things come along that change fundamentally the trade-offs in the system. And suddenly an old approach that was worse is suddenly better, or a new approach that no one's considered is suddenly better. And, I think I saw a paper, 5 years ago, maybe it was a little more now, where someone had just beaten the record for in-memory string sorting, the most kind of basic-ish thing. And by just challenging an assumption of like pointer swizzling, like saying, hey, I'm going to move the actual data around. You're actually better doing this than you are, moving around pointers to data in memory in certain cases. And so there's lots of these very interesting things where very fundamental building blocks then result in changes in the overall algorithms and approach. Obviously changes in compute substrate. So moving to massively multi-parallel processors, such as a GPU, that could lead to massively different performance, but only for certain subsets of problems, or only if you recast the whole problem a certain way. So I don't know what the next one looks like, to be honest.
And I'm curious to know, what are the features that are currently developed in Amsterdam? I know for sure workflows, but what are the other features?
Yeah, I mean, we work on many different pieces of Databricks because we're the oldest satellite office of R&D in Databricks, and the largest one outside the US. So we have quite a few different project areas, but our focus areas first is, Lakeflow. So that's workflows or jobs, part of the stack, top to bottom, everything from the UI, UX through the control plane, how we manage the data plane. That's done in Amsterdam. But also we are working now on the DLT products, so how we make, declarative pipelines work in addition to imperative ETL, like we do with jobs. So we're working on that. We work on most layers of the storage stack of Databricks. So Databricks is giving you the performant, giving you a performant data warehouse and a performant, data lake on top of your blob storage from your cloud vendor. So GCP or S3 from AWS, for example, you've got your data sitting there, and we need to give incredible performance on top of that, eventually consistent, somewhat, slow storage. So it's a very interesting problem to solve. And so everything from low level, how do you read and write as rapidly as possible and parallel as possible to the storage layers, to how do you govern that data, that whole stack, how do you encrypt the data, how do you give abstractions of that storage system, how do you make 3 different clouds work in a way that's consistent for our customers and for ourselves, because we have a product that is agnostic of the 3 clouds for the most part for our users. Basically, that whole surface is worked on in Amsterdam. It's another major area of focus of the site. We also have people working on all sorts of other problems on, I don't know, I'm trying to think of a few things, like looking at Unity Catalog also falls into there. There's, we're trying to make sure you can govern and secure those storage assets in Unity Catalog and expose them as, for example, volumes. We have all efforts on how you automate the use of Databricks through SDKs, the command line interface, IDE integration, Terraform, all those types of capabilities, those are all built here. We also have smaller teams that work on internal developer tooling, how our own developers write code productively, how lifecycle of VMs that are used for compute are handled, and many other sort of areas of the stack. So a lot of it at this point.
And I'm sure a lot of folks would love to know a bit more about the internal stack at Databricks. Do you think you could share a bit more maybe on workflows, what we have, how is it working at a high level?
Yeah, so if you think of a product like Workflows, so Workflows is a product that, for those who don't know, allows you to orchestrate your ETL on Databricks. So I have a sequence of tasks I want to operate on a trigger. For example, a time trigger. So Friday at 9 p.m., run the following sequence of things in order, run this notebook, and then do this little blob of API calls and so forth, and write the results over here. You want to get this done. There's a few different pieces of that software stack. At the top level, you've got a web app sitting in front of you. You're sitting in front of a web application. You're using a UI for the form and for boxes and layout and so forth. That's your classic web sort of stack. We're using... sorry, I'm just finding my notes here. Yeah, so, sorry, let me...
Let's cut here.
Yeah, we'll cut here for... I had the wrong version of my notes up, so I'm trying to find it, and it's got the wrong data in it. Right. Okay. So if we look at the web, the sort of the first layer, let's restart from here. So we have the workflows. You have a UI where you're authoring your workflow in it. That authoring experience is a classic web application. It's written in React and TypeScript, communicating via GraphQL with the APIs in the backend. There's microservices sitting in the control plane of Databricks. So these are, machines running within Databricks' environment that are handling all of the API requests and all of the backend that supports this web application. You've got, those are written primarily in Scala these days, though we're slowly starting to write some of them in Rust or a few things in Golang. But primarily we're a Scala house when it comes to most of our control plane software and microservices. Those services are reading and writing their state into, MySQL and TIDB as the backing stores. And then that's kind of sounds not much different than most full stack sort of development environments. What's kind of interesting and special is we're, also as part of that workflow, we're spinning up compute on behalf of the customer. So we're acquiring VMs from a cloud vendor. So let's say it's AWS, you're getting an EC2, you're getting VMs from EC2, and you're administering them on behalf of the user in the user's account and executing on data that's sitting in the user's account in S3. You're installing a Spark runtime on that VM, which then does the distributed data processing of the data on behalf of the customer. So all that lifecycle is being managed under the hood in this Workflows product. The software that's installed on the VM is things like that Photon engine I mentioned earlier, but Spark itself is written primarily in Scala, with pieces of it having been rewritten in C++, as well as Rust in places now. So that's kind of the tech stack that we work on. So the majority of our work is done in Scala, which is a JVM-based language. And that's for historical reasons, because the original Spark or Apache Spark software was written in Scala, and that's where we evolved out of. But we are starting to use other languages where they make sense for our stack.
I didn't know we were using Rust. I know they're using Rust for some Delta pieces, but it's cool to know that we have Rust.
Yeah. But that's where, C++ and Rust are basically used in places where we absolutely need, the maximum performance. And we also want very good control over the memory consumption of the software because, other languages can be more bloated, and that bloat can be problematic when it comes to efficient computation in the bottom of the stack. So that's the primary place where we're starting to deploy it here and there.
Since you're talking about boosting performance, what about boosting performance of the software engineers? I know with the rise of GenAI, we started using a lot of, tools like Cursor AI or Copilot. Is it something that is currently encouraged to boost the productivity, or?
Yeah, definitely. Our engineers are definitely looking at and encouraged to use GenAIs in their day-to-day work in various ways. Obviously, it's amazing for certain coding tasks. So where we have validated and approved the use of these AI tools, we use them in our day-to-day tasks of programming, and people keep discovering new ways that it's awesome and other ways that it's not so awesome. And this keeps changing every few months as these tools get better and better, and the context that they understand and so forth. But examples. Writing unit tests is one of the things that the AI coding assistants are actually quite good at. They're very good at writing tests that test the code you've written. And in the process of doing that, you'll be like, oh, hey, that's the wrong unit test. It's actually because your code maybe was not actually implementing the right thing. So that's an example of somewhere where some engineers have found that useful. It's very good for code fragments. It's sometimes great for large changes across large parts of the code base. Different people have had different success with different recipes. We try to share some of those examples with each other, so people are learning from one another on how to be more productive with applying AI in their day-to-day work. The other area is obviously non-coding work. It's like everyone is finding these useful for various forms of technical writing, or non-technical writing even. Taking 25 peer reviews for someone and summarizing those peer reviews into a summary of the pros and the cons from the peer review, or the areas of feedback, was a useful technique I used in the most recent performance review cycle we did, where I just wanted to make sure that my own summary of what I thought I had read from the peer feedback, is that actually reflecting, was I subconsciously biased here, and I was removing information that was in fact present, and I was just not listening to it. So it was a very interesting way to cross-check what my summary was with what a machine saw.
Yeah, that's a good point. I use it a lot also on PR. Just, when I send a PR, I have my little agent and they come and they kind of double check everything for me. I think it's super useful, especially for open source project. It's like you have your top senior advisor just checking everything you do behind you. It's super nice. And it's unbiased. As you said, he's just gonna, the AI is just gonna give you honest feedback, and that's it. So it's really cool. Do you see that being used? Oh, sorry, go ahead.
No, sir, go ahead.
Do you see that being used also on, in the learning steps? There is this kind of big discussion on what do we do with the, kind of new data software engineer now? Because basically you hire someone fresh from the college, they will have kind of the same level as an AI, maybe not at Databricks because we do maybe, specific engineering stuff, but in, a lot of companies, that's kind of going to be the case. And then the question is, okay, so if they are just as efficient, should I just get the AI instead? But then if you do that, how do you ramp up to the next level so that you can get better than the AI?
Yeah, I think that if your viewpoint is that you're hiring junior engineers because you need hands on a keyboard, then I can see why one might come to that conclusion. But I don't think that's the reason we hire junior engineers. We hire them because, well, they are strong students. They have learned a lot of good theory and have learning how to design well and have critical reasoning they bring to the table that still isn't, sometimes the AI will only design the thing you tell it to, or write the thing you tell it to. It's not going to actually figure out where the gaps are between what, the problem in writing software often isn't how do I literally write the code that does this. It's what's the right thing to write in the first place. What's the right problem to solve? Is this the right thing to build at all? And that's not a thing that I shouldn't say never, because these AIs are super, super, impressive at how good they're getting. But That's not the, that's the thing that you need really strong engineers behind the keyboard to continue to do. So, for junior engineers, AIs can be a great productivity boost. I mean, I think of it a little bit like, I don't know, when word processors came out, and then, spell checkers and grammar checkers, and now even LLMs. LLMs can write an essay for you, but if you just hand in LLM written essays all the time, you never learn the critical reasoning you need to understand how you make an argument. You can't judge whether one argument's better than another. There's a lot of, stunting in your own development that arises from that. And so I think that the act of being very good at reading code quickly becomes more important, I think. It's like, the AI can produce lots of code. You have to be able to read and look at it and learn from it, find problems from it, figure out how to adjust it to get to the real best solution. And so that sort of insight you get from looking at what the AI wrote and then modifying it, I think it can be a great accelerant to your ability to write code. I think it also bridges language gaps. So, for example, you might know one language and not another. Where we hire people not because of a particular language they learn, because we expect them to learn the language over time. But with AIs helping you, you can very, very quickly start writing code in an unfamiliar language or to an unfamiliar API surface, and gets rid of a lot of the whole, hey, how does this API on that service work kind of grunt work that you do as an engineer, and lets you spend more of your time doing what you intended to do when you sat down at the keyboard in the first place, which is build the intended functionality you're aiming for.
Yeah, no, you're right. And I think it's super useful to learn new things, like new functions of the language or new ways of doing things. Sometimes I do that, and then I would get a new, I don't know, library or new function. I'm like, wow, we can actually do that. It's super cool. And then you learn about it, and you can go to the next stage.
And since Paul, you mentioned recruitment, what are the skills you're looking for when it comes to a software engineer?
I think we're looking for really strong problem-solving ability. It's the skill we want is the ability to learn, the ability to look at new problems and synthesize information, boil things down to first principles. Like, can you take a problem and figure out what is at the actual core of this problem? What's the problem behind the problem, or what's the question behind the question, right? And that level, so that kind of reasoning is what we're looking for. So obviously the ability to demonstrate this through problem solving live, being able to write code, write algorithms, solve a systems problem, these types of things like many tech companies look at. But you're looking for that sort of ability to also adjust your thinking with new pieces of information or a hint. And software engineering is not a lonely, vocation. It's not one where you sit in a corner writing code. You are often working collaboratively with others to solve problems. So when working collaboratively with an interviewer, for example, can you take a new piece of information and turn it into an adjustment to the solution that you're building? Because that's what the real world looks like, much more so than a statically defined problem. We're also kind of looking for some signs that the person has sort of hustled or worked hard at something, and that they have some resilience. What will happen when you inevitably face challenges in your job, when the job gets hard or when circumstances get difficult, how do you respond to those challenges? And this is where we look at the nature of the experiences people have had and what they've done in the face of those experiences. So those are some of the things we look for. Along with probably a lot of the same things most tech companies look for, strong academics.
And for those who are interested, we're going to put the link of all the roles open in Amsterdam in case you want to apply.
Right. And just to be clear, you'll see a list of roles available at Databricks, and there's probably other roles that aren't even listed that you might be appropriate for. So feel free to apply anyway.
Are you working remotely? Is it mostly remote, or are you going to the office?
No, we're in the office currently 2 days a week, and going to be increasing that to 3 days I imagine in the near future. So we do like to spend time with one another to increase the amount of collaboration. It helps also with the innovation that we talked about earlier.
Yeah, and then plus because it's in Amsterdam, so you can go super easily to the office. You can just take your bike and you're good to go. So it's easy and nice.
And regarding the performance, so how do you measure the performance of an engineer? I know it's a tricky question, but how would you measure it?
I mean, obviously, it is somewhat subjective in the end, but it's based. You're looking at the impact people have. So the things they built, did they work the way they were intended to? Did if you've designed a software system, did that software system survive the fires of launch and use in the wild? Did it fall over once it was faced with real workloads? Or if you were designing a product, did it meet the job to be done of the user? Did it find product market fit? If you're a more junior engineer, you needed to write code. Did you write the code cleanly? Did it work? Does it look good when it's reviewed? Do you work well with your peers in iterating and improving the quality of that code? So obviously there's a number of sort of outcome related things we look at. So you're not measuring the inputs as much as you are the outputs in terms of what happened, not for example, the effort that went in. You're also looking at whether you're making the world around you better. So are you helping your teammates be more productive or more, helping them improve? Are you mentoring? Are you helping hire? Are you helping the code base look better? Are you building tooling that make the people around you more productive? These are all sort of leadership and citizenship types of contributions that we look at. And we're looking at also how your basic skills and tools are developing. Like, are you starting to develop the skill set you'll need in order to be successful, not only at your current level, but at the next level? So, the nature of software engineering jobs changes as you work your way up through seniority. The nature of the problems you're solving and the skill set you need to have changes through that evolution. And so we're also helping our engineers grow those skills and helping give them feedback on how that growth is going.
All right, thanks. Well, look, that was super nice to have you. Maybe one last question. Do you have any insight, any advice for aspiring engineer that's want to become a leader? I know you have been super successful. Like how can they become a Paul Leventis?
That's tricky. I'd say career advice is hard. I think the first thing I'd say actually is everything's easier when you're doing something you love. So following what you're passionate at and what you're good at is a lot easier than like doubling down on your strengths, and what you find over time that you're kind of uniquely good at in your environment can be a great way to progress in your career or progress in your own development, and have maximum impact in the environment you're in. So figuring out what that is, and it's situational. Like, you might be awesome at one thing. I'm very good at solving specific types of software optimization problems, but somewhere along the way, there were 10 other people who were good at that, but none of them were good at, let's say, looking at how to build a system that crossed departmental boundaries. But I was good at going and understanding the broader system and could solve problems that others weren't seeing. So it's just an example where you need to be looking at what you're good at relative to the environment you're in and trying to maximize that. The second thing is don't optimize for the short term. I think it's really important to be looking at how whether what you're doing is growing you, where do you want to be long term? And often people make short-term choices. They jump ship for a small increase in compensation and they do it 3 times in a row in 3 years. And next thing you know, you haven't built the knowledge and experience you need from having seen something all the way through its life cycle. So until you've seen a software system, you've designed it, you've seen it roll out, it's worked successfully, and then it's fallen over 3 years later due to the new requirements on the system. And in thinking back how I would have changed, or should have I changed anything, or maybe it was fine. There's a learning you get from sticking with a company, with a group, with a team, with a project for a particular period of time that is worth something in your long-term trajectory that may not be apparent to you when you're on the journey. And so figuring out the right time how long to stick with something and when to make a small change locally within your team, across teams, across companies, or jumping continents. Those are important choices to make. But don't be afraid to take a big, crazy change too. I went and ran an office in Vietnam. I learned I did not want to be a general manager, was one thing I learned from that experience. It was a wonderful experience. And then I also made the jump to come to Amsterdam, and it's been an amazing experience with Databricks. And so I'm really glad for both of those opportunities, even though one of them probably objectively on paper looks like it probably led to more than the other, both of them help shape who I am.
That was perfect.
Well,
Cool.
Thank you so much, Paul.
Awesome. Well, thanks for having me on the show. And that was fun.